This is Pre-Calculus Section 1.1 Day 2 Notes. Today we're going to be talking about set notation. A set is a collection of objects called elements. So here we have three set examples. We have M, N, and Q. And each of those are a set of numbers, and so those are given to us. So number one, we're just kind of learning about notation here. We've got a 2 with this symbol and then the M. And so what that means is that 2 is an element of the set M. Example number 2, we have 17. Then we have that little symbol, but it's got the slash through it. This means that 17 is not an element of the set M. Next, we're going to talk about unions. So when you see a union, it's going to look like this. We could have set S, union, so it just looks like a big capital U, set T. Okay, so this is read the union of S and T. So the union of S and T is the set that contains all of the elements that are in S or in T or in both sets. So another example, M union N, if we look back at our sets that we were given, M is 1, 2, 3, 4, and 5, N is 2, 4, 6, and 8. So M union N would have to be 1, 2, 3, 4, 5, but then also 6 and 8. Because basically these are all the elements in set M and in set N. An intersection is basically the opposite of a union. So an intersection we written like this. The intersection of set S and set T, it's like an upside down U, and this is read the intersection of S and T. This is the set that contains all the elements that are in set S and in set T. So in order to be in the intersection of them, it has to be in both. So now when we look at our two sets M and N again, but now we're looking for the intersection instead of the union, we're looking for what elements are in both sets. So for M and N, the two elements that they share are just 2 and 4. The intersection of N and Q, well, when you look at N and you look at Q, they don't have any elements in common. So we would call that the empty set. That's written like a 0 with a slash through it. That's the empty set, which means that they have no elements in common. Setbuilder notation is another type of notation that we used. And it looks like this. You've got kind of a bracket with an X, and then you have an inequality that shows where X lives. So I could say 0 is less than X, which is less than 7. Okay? So this would be read as all positive integers less than 7. Okay, so this set builder notation uses words and or simple symbols to define the set. So here's another set, W, 1, 2, 3, and 4. We want to write this using set builder notation. Now, there's more than one way to do this. I'm just going to give you two options. Option 1, we could say, this is set W, and we'll say W is, an integer. And then we could say 0 is less than W, which is less than 5. Okay, so remember the less thans mean not including 0 and not including 5, right? So just integers between 0 and 5, which would be 1, 2, 3, and 4. Another way we could write this. We could say W is the set, and W is an integer, and we could say 1 is less than or equal to W, which is less than or equal to 4. And there are other possibilities. Okay, so there is no one unique way to write an answer in Setbuilder notation. Okay, now we're going to talk about interval notation. And this is new material as well. So interval notation, when we have an open interval, okay, we would say if A is less than B, then it's going to look like this. We're going to have a rounded parentheses, A, comma, B. Okay, so what this means is all the numbers between A and B, but not including A and B. So that's what the round brackets signify, okay? Open intervals signify, or round brackets signify an open interval, meaning not including the endpoints. So if we were going to graph it, here's A, here's B. So all the numbers between A and B would look something like that. Now if we had closed interval, and again, if A is less than B, because obviously the smaller number is always on the left and the bigger number is always on the right. So that's just kind of general rules of math. Then we would write it like this. We'd use square brackets, then A, comma, B. Okay, so closed interval is denoted with a square bracket. So again, this means all numbers between A and B, but this time it's where A and B are included. So if we graph this, we've got A, we've got B, but this time if we're including A and B, we're going to use closed circles, and we're going to show all the numbers between them are included. So if we want to express the interval in terms of an inequality using Setbuilder notation, and then we want to graph the interval. Okay, so when we look at this, I notice that we have a rounded bracket on 2 and a square bracket on 8. So that means that 2 is not included, and it means that 8 is included. So if I'm going to use Setbuilder notation, I'm going to say we're talking about some variable. We can call it x. You could call it anything you want, but we'll call it x such that 2 is less than x, which is less than or equal to 8. And if we were going to graph this on a number line, we'd need a 2 and we'd need an 8. 2 is not included, so that's going to be open circle. 8 is included, so that's going to be closed. And we're talking about all the values that live in between. Okay, number 2, negative infinity, comma, 4. And we've got rounded brackets on both, okay? So we're going to make a little note here. And our note is going to be that there is never a closed bracket. With infinity, okay? This indicates that there's no endpoint, that it extends infinitely far. So just keep in mind that whenever you have infinity, you're always going to have a rounded bracket because we can never truly reach infinity, right? That's kind of the definition of infinity. So if we were going to write this in Setbuilder notation, we would say all values of x such that x is less than 4. Remember, not including 4. So we can't say less than or equal to because we have that round bracket. If we're going to graph this, we just need a 4 on our number line. We need an open circle on that 4. We go all the way to negative infinity, so we just shade all the way to the arrow, and that shading just goes on forever. Okay, our next set of examples, we want to express these in interval notation. So if x is greater than 3, okay, first of all, greater than 3 means not including 3. So 3 is our left-hand limit here. Not including means it's a rounded bracket. And if it's any number greater than 3, then it's going to be comma infinity. And as we just talked about, infinity always gets a rounded bracket. The next one, x lives between negative 3 and positive 9. It's less than or equal to negative 3. So our lower endpoint is negative 3, and negative 3 is included. So we're going to do a square bracket on negative 3, comma. Our upper limit is positive 9, but 9 is not included. So we're going to do a rounded bracket on 9. Okay, and then our last examples here, it says graph the sets. Graph the two sets off the number line. This is our hint. Then select the union or intersection of your two graphs and graph that on the number line, okay? So first of all, remember that this here means that we are looking for the intersection, okay? So what I'm going to do is I'm going to graph that first interval, -2, 0, above my number line, okay? So what is that going to look like? Well, let's see here. We'll say -2 is right here. We'll say 0 is right here, okay? We know we have a rounded bracket on -2, so that's going to be an open circle, and a rounded bracket on 0, so that's going to be a closed circle, okay? And we're looking at what lives between there. Okay, now we've got another set that we want to look at, and we're going to look at this below the number line. And this set goes from -1 to +1, but again, those are both closed circles, or excuse me, both open circles, because they're rounded brackets. Okay, so if we want to know, again, the intersection is what do the two sets have in common? Okay, so where's the overlap? That's what we're looking for. Where's the overlap? Well, the overlap looks like it's between -1 and 0, right? That's what both of them have in common. But we can't include -1 because the bottom set doesn't include -1, and we can't include 0 because the top set doesn't include 0. So basically, we're going to have from -1 to 0 with open circles on both and shading in between, okay? And this right here is the graph of the intersection of those two sets. Let's try another one. This one is a union. Okay, so we're going to graph that -4 to 6 on the top. I'll call that -4, and I'll say 6 is up here. Okay, so -4 has a square bracket. That's going to be a closed circle. 6 has a round bracket. That's going to be open. And we're shading between. Okay, now our second set here, we're going to graph underneath our number line. And that goes from 0, say 0 is about right here, to +8. And again, we've got closed bracket on 0, and we've got open or closed circle on 0, and we've got open circle on 8 because we've got a square bracket on 0, and we've got a rounded bracket on 8, and everything that lives there. Okay, so if we're supposed to graph the union of these two sets, basically it's everything that belongs to both sets. Okay, well, the top set contains our lower limit, that's -4, and -4 is going to be included. So we're going to have a closed circle on -4. The upper limit is in our bottom set, that's at +8. That one's not included, so we have to have an open circle. Now the question is, what about that 6? Okay, well, the 6 isn't included in the set on the top, but it is included in the set on the bottom. Okay, so that just means that we can shade everything in between -4 and +8. And that is going to show us the union of these two sets.